In our previous video, we demonstrated how to use the analog input pins on an Arduino UNO to read joystick positions. We then showed how to wirelessly transmit this data to another microcontroller board using nRF24L01 wireless transceiver modules using the 2.4 GHz band. In today's video, we will demonstrate how to build a robotic cart that can be wirelessly controlled using a joystick. We will be using the same components as shown in the previous video to build the remote controller for our robotic cart. To drive the cart with two motors, we will need a motor driver card as the microcontroller's I/O pins cannot drive the motors directly. For this purpose, we will be using the RF Nano board and the motor driver card. If you need more information on motor drivers and how to use them to drive and control DC motors with microcontrollers, we recommend watching another video available on this site. You can find the links to both of these reference videos in the description box. To move the cart in any direction, we need at least two motors. Each motor drives a wheel. When both wheels rotate in the same direction, the cart moves forward. If the wheels change the direction of rotation, the cart moves backward. To turn the cart, we can drive the motors in opposite directions relative to each other. The RF Nano board on the cart acts as the brain for the motors, receiving joystick position information to drive them. I can demonstrate how the cart was built. The assembly process is simple and straightforward. The mechanical components required are readily available. We're using DC-geared motors rated at 9 volts. Only one 9-volt battery is needed to power the RF Nano through its VIN power input pin. The same battery also provides 9 volts to the motor driver chips used for driving the motors. The breakout board used is based on TA6586 and can operate two DC motors in either direction. The connection between the RF Nano board and the driver breakout boards are simple. The two pairs of output pins, A0 and A1, and A2 and A3, respectively, drive the two motors connected to the terminals D0, D1, D2, and D3. The ground pins of both boards are tied together with the 9-volt battery negative terminal. The VIN pin of the RF Nano board is connected to the positive terminal of the 9-volt battery through a switch. The terminal block connectors on the opposite side connect to the motors. The power connector on the driver board receives supply from the 9-volt battery through the switch. When the switch is turned on, both the RF Nano board and the driver board receive power from the onboard 9-volt battery. Now that the cart is assembled and connections are made, we need to upload the sketch onto both the RF Nano board on the cart and the remote controller. Let's go over the sketch for the remote controller first, which transmits the joystick position to the cart. The sketch is quite similar to the transmitter sketch discussed in the previous video. The only change made in the code is to send the joystick position only when it has significantly changed. Whenever the analog value recorded from the inputs connected to the X or Y potentiometer changes by more than 100 counts from the previous reading for a corresponding axis, the X and Y position counts are transmitted to the RF Nano board via radio. Rest is pretty much the same as the transmitter sketch shared in the previous video. The transmitter sketch is uploaded into the Arduino UNO, which has the joystick breakout board and nRF24L01 radio assembly on it. Let's review the receiver sketch, which will be uploaded on the RF Nano board driving the cart. The sketch receives joystick positions from the radio and controls the motors accordingly. Functions for different cart movements are defined. Note that analog read function controls motor speed with values from 0 to 255. When you use the analog read value of 255, it will provide a continuous high voltage to the motor terminal. This will cause the motor to rotate at its maximum speed. On the other hand, when you use the value of 0, it corresponds to a voltage that is close to 0 being applied to the motor terminal. Any value in between will provide a PWM signal, which allows the speed of the motor to be adjusted to a speed that is somewhere below its maximum speed. In the video, we utilize geared motors with low speed, hence, we use the maximum value of 255 to drive them. The loops function uses a case statement to select the appropriate movement function based on the joystick position values received. To receive the joystick position data over the built-in 2.4 GHz radio module, refer to the previous video. The links are provided in the description box. Once the sketch has been successfully compiled and debugged, it can be uploaded to the RF Nano board that is installed on the cart. We have attached another 9-volt battery to the controller and added a switch to the power circuit to turn it on or off as needed. All is now done to test the remote-controlled robotic cart. Note that the sketches shown in this video were written very quickly for this demo, and there are opportunities to improve the sketches further. It is demo time now.